Today we are going to talk about the inductive and deductive reasoning. We're first going to start with 2.1 inductive reasoning, and then we're going to transition into 2.4 deductive reasoning. First, to kind of get our minds going here about inductive reasoning, I have kind of a challenge for you, but I think you can do it. What will be the 25th shape in this sequence? Okay, I want you to be able to draw it or be able to explain how you would determine it if it's going to be too complicated for you to draw. Okay, so take a minute, pause the video, okay, and determine what the 25th shape of the sequence would be. All right, hopefully you figured it out or have a good educated guess. Okay, and I'm sure you have your reasonings on how you came up with your answer. The 25th shape of the sequence would be a circle with the top part shaded. Okay, now how I determined it, I noticed that these were the odd ones. Okay, so I put in the last of the circles just for my own mental sake. Okay, and then I went through and I thought about, okay, that's the 7th. So this one would have to be the 9th, the 11th, 13th, 15th, 17th, 19th, 21, 23rd, and then I got back to the 25th. So that's how I determined this shape to be the 25th. All right, so now that you kind of maybe have some ideas, what would the 30th shape be? Okay, I want you to be able to draw it or explain it. If you think it's too complicated, please pause the video to determine what the 30th shape would be. All right, so hopefully you paused the video and came up with an answer. It will have a 31-sided polygon with that same triangle pattern. Okay, so how I determined it was I knew that all the polygons, 5, 7, don't know what I'm thinking here. All the polygons were the even numbers. So I knew that, okay, 30th is an even number, so it has to be a polygon. And I noticed that all the polygons had one more side than each other. So like the second figure has 3 sides, the fourth figure had 5 sides, and the sixth figure had 7 sides. So I figured if we kept going to the 30th figure, it should have 31 sides. All right, hopefully it got your brains thinking and moving a little bit. Let's get started on what inductive reasoning means. So I would write this down on the backside of your conjecture sheet. Okay, so that conjecture sheet that you either printed off or your teacher gave you, okay, write it down in your notes somewhere. Inductive reasoning is observing data and patterns to make generalizations about those patterns. So thinking back to those warm-ups we did, okay, we made some generalizations about what pattern was happening and what was going to happen next. We didn't know 100% what shape would pop up next or on the 25th or 30th, but we made some we observed, we noticed, and we made some generalizations about what could possibly be next. So inductive reasoning is all about patterns, observing. Another vocab word that you should write down is a conjecture. And now a conjecture is a generalization or a hypothesis that you made from inductive reasoning. Okay, so, okay, we noticed this and this. Okay, so now it must be, we have some proof to back it up. Okay, but it's not like 100% confirmed. Okay, so a conjecture, okay, or sometimes you might hear them be called like theorems. Okay, other textbooks use postulates. Okay, so a conjecture are just kind of like a bunch of rules that we are going to use. So every unit you're going to have a conjecture sheet. Okay, and you can kind of glance at the front of it and kind of notice that there are rules for us to follow. We're just going to do a few more practice of inductive reasoning. Okay, so trying to figure out the next one in the sequence. Pause the video, see if you can come up with it. Hopefully you came up with the same number as me. I noticed that they were just adding numbers and then repeating the pattern backwards at the end. Next one, okay, pause the video, see if you can find the next term. Okay, so I notice here that 1 plus 1, we get 2. 1 plus 2, we get 3. 2 plus 3, we get 5. So I notice the two previous ones we are adding together to get the next one. So this one would be 34. Last one, little geometry here. Okay, use inductive reasoning to determine what is next in the pattern. So pause it, maybe you can draw it. So hopefully you had a pentagon, 5 sides, and then have all of the diagonals drawn in. So a little star in the middle. All right, next we are moving on to deductive reasoning. Deductive reasoning is a little different than inductive reasoning, but they both kind of work together. Deductive reasoning is using agreed upon assumptions and proven facts to logically show that something is true. Okay, so inductive reasoning, we do it just based on our observations and patterns before us. And now deductive reasoning, we use like cold hard facts. Okay, when you use deductive reasoning, okay, you try to reason in an orderly way. So like showing your work in math class, right? Ordering it, okay? Or convince that someone else has that your conclusion is valid. Okay, so kind of proving your point. Okay, so thinking about this, inductive reasoning was patterns. Deductive reasoning is using facts, okay, using knowledge that we know is true to explain it. So I want you to think of a career that uses cold hard facts to prove something is true or something is false. To prove whether someone is telling the truth or not, if they are guilty or not guilty. Okay, so lawyers, they use deductive arguments all the time. Okay, they try to find the evidence to back up their client. I'm not going to go through this, but this would be another example, a math example of deductive reasoning. Okay, if you want to solve this for fun, you can, because I know algebra is fun. I know you all miss it. Okay, so deductive reasoning would be like, okay, first I'm showing you I did the distributive property. Okay, then next I combine like terms. Okay, and showing me your work, that is deductive reasoning. You're showing me that you know what you're doing. Then a geometry example here. Okay, I have 3 obtuse angles, BAD, obtuse, obtuse, and obtuse. Then I also have a bisector. And I noticed in these 3 examples that when I bisected an obtuse angle, that the 2 newly formed congruent angles are acute angles. Okay, so they are acute because there's no way we could have the biggest obtuse and the smallest obtuse, and they would always be acute angles.